All right, so as I said, that a line that's written in slope-intercept form is written in the form y equals mx plus b. And the reason why it's called slope-intercept form is because the slope and the y-intercept are explicitly stated. All right, they're in the equation. So today we're going to look at how to write an equation depending on what information is given, and we're just going to practice that. So this first type of problem would be like if I give you a slope and the y-intercept, how do you write the equation? Well, you're just going to sort of fill in the numbers in the formula, right? This y equals mx plus b. So when it gives you the slope and the y-intercept, that should be super easy, right? The slope is m, the y-intercept, that's your b. So you just sort of plug them in where they go, right? So if the slope is -3 and the y-intercept is -1, your equation would be y equals -3x minus 1. Now most of the time it's not going to be that easy, right, where I just like give you the slope and the y-intercept explicitly. Usually I'll give you some other information where you have to figure it out. But as soon as you know what these two things are, you can write your equation. If the slope is 2/3 and the y-intercept is 0, you just do the exact same thing. Y equals 2/3 x plus 0. Although you don't really need to write the plus 0, do you? Right? You're adding 0, you're not really doing anything. So a simplified form of this equation would be y equals 2/3 x, where the plus 0 is implied. Well, this will be a little different if the slope is 0, right? Do y'all recall what a line with a slope of 0 looks like? So a horizontal line, right? So yeah, so it just goes like from left to right. Yeah. So the way that equation typically will look is it's just y equals some number, so like y equals 5 or something like that. And the reason why is if we plug these numbers into our y equals mx plus b equation, we get y equals 0x minus 2, which if you leave it like that is fine, but 0 times anything is just 0. And so that's why you end up with an equation with no x, because the slope is 0. So you just get y equals -2. So this represents all of the coordinates where y is -2, which would be all of those points that are horizontally aligned where y is -2. So any questions on writing the equation given the slope and the y-intercept? All right, well, let's make it a little harder. Okay, instead of me just explicitly giving you those two pieces of information, let's say I give you a graph and you have to find those two pieces of information. It's not that hard, but you just have to know what to look for. So the easier thing to find in almost every case is the y-intercept, because all you're looking for the y-intercept is where does the graph cross the y-axis, the y-axis being this vertical axis. So for this one, what's the y-intercept? -3. In fact, maybe we should just go through these three problems and sort of work them all simultaneously. Right? Like let's find the y-intercept on each one of them, we'll find the slope on each one of them, and then we can write our equation. So what's the y-intercept for letter B? 2, right? It's this point right here that we're looking at. So the y-intercept is 2 in this case. And what's the y-intercept for the last one? Yeah, 1. So the y-intercept is usually pretty easy to find, right? That's your b value. That'll be your constant that you're adding to your function. Now let's talk about the slope. So the slope is calculated as the change in y over change in x, or if you're looking at a graph, you want to think about it as being rise over run. So to get from this point to this point, how many units do I need to go up to get from -3 to 3? 6. So plus 6, right? And then if I run to the right, I have 4. So my rise over run will give me my slope, in this case 6 over 4. which reduces to 3 over 2. Yes, ma'am.
Is there a y-intercept negative? Negative 3?
Oh, yes, it should be negative 3. Oh, goodness. Wow. Not a great way to start today off. Yeah. Good catch. Yeah, it should be negative 3. Oof. It's minus 10 points right there, yeah. Okay, so now we've got the y-intercept and the slope. So let's write our equation. Y equals 3 over 2x, or 3 halves x, minus 3. Now, if you're ever not sure about, like, oh, am I writing the equation correctly, you can always put it in the calculator and see what it looks like. Okay, like, type it in, the y equals menu, look at the graph, and see if, like, these coordinates are still, like, where they're supposed to be. All right, well, let's find the slope on the next one. So what is my rise? Now, typically when I say rise, I'm thinking of going up. So if I'm rising going down, what's sort of the consequence of that? What does that mean? Yeah, it should be negative, right? So if I'm going down 1, 2, 3, I'm going to say that my, quote unquote rise is negative 3. Now, whenever you're finding the slope, you're always going to be running to the right. So typically, you don't have to worry about the run being positive or negative, only the rise, right? You're either going up or down, but you're always going left to right. So if we go left to right here, you can see that our run is 1, 2, 3, 4. So my slope is negative 3/4. Now that I have my y-intercept and my slope, I can write my equation. Y equals negative 3/4 x plus 2. What about this last one? What's the rise? 2 plus 2. What's the run?
4.
Plus 4. Right, so my slope will be 2 over 4. When we reduce that fraction, what do we get?
1/2.
Yeah, 1/2. Good. So my equation would be y equals 1/2 x plus 1. All right, so let's say instead of a graph, you're just given 2 points that are on the line, and you're trying to find the equation. Now, for now, these are going to be set up in a way where one of the points is going to be the y-intercept. So it makes finding that y-intercept pretty easy. Now, moving forward, like when we start looking at the other forms of the equation next time and going forward in this unit, you won't necessarily get the y-intercept as one of the 2 given points, and you would have to find it separately. But for now, just know that if you ever see 0, something, that is going to be the y-intercept. All right, so you look for that 0, something point to be your b value. Right, this right here is the y-intercept. Okay, so just keep that in mind. We still need to calculate the slope, though, right? So when you're calculating the slope from either like a table or just a list of points, you're going to find the change in y over change in x. So let's do the change in y first, the rise. How do I get from 5 to negative 1?
6.
Yeah, minus 6, right? Let me give myself a little bit more room here. Or here, I'll do this. Let's see. So minus 6, that's my change in y, right? Notice I'm not really using it. You can use the formula. You can plug the numbers in and calculate it that way. That's fine. I just think this is so much easier to do it this way, that you don't even have to think about what the formula is. As long as you know it's the change in y over the change in x. So what's the change in x? How do I get from negative 3 to 0? Plus 3, right? So my slope will be negative 6 over 3, and how does that reduce or simplify?
-2.
So yeah, just negative 2, right? So my slope is negative 2. My y-intercept is going to be just sort of given implicitly. 0, negative 1. So my y-intercept is -1, and I can write my equation. So with all of these problems, whether you're given like function values or coordinates or a table or a graph, you're sort of doing the same thing, right? You're identifying the slope, identifying the y-intercept, and then plugging those two numbers in your equation. So we've got y equals -2x minus 1. Let's try another one. 0, -5, 8, -5. All right, well, what's my change in y? How do I get from -5 to -5? Nothing, right? Just 0. So plus 0. And how do I get from 0 to 8? Plus 8. Very simple, right? So the slope, move this over so you can see. The slope would be 0 over 8, which is just, careful, 0. Yeah. And if you're ever not sure, like the calculator will reduce fractions for you. You can just type it in as a division problem. There's no reason to like stress out about simplifying this correctly. Like let the calculator do that work for you if you need to. All right, and what's the y-intercept? So this one's given implicitly. Yeah, 0, -5, it's got to be -5. So I'm going to set it up. I can see that my slope's going to be 0, so something definitely kind of funky is going to happen here, right? When my slope is 0, we talked earlier about how that's going to create a horizontal line. So we can expect that once we simplify our equation, it's just going to be y equals some number. And you could probably tell what that number is going to be because you know what the y-intercept is going to be. So what you should be doing is sort of visualizing in your head, okay, well, if it's going through -5 and it's horizontal, like you should already kind of know what the graph is going to look like, right? So anyway, let's plug everything in and simplify it. So y equals 0x minus 5. So 0x is just 0, and this is where you get that equation where it's just y equals some number. And anytime you get that, where it's like y equals 5, or y equals 2, or in this case, y equals -5, that's always going to be a horizontal line because your slope is 0. Now, sometimes I'm going to ask you a question that's just like this, but it'll use function notation. So it'll look more complicated, but it really is, you're doing the same thing. Like in C, saying, find the equation of a line that has these two function values, at where f of 0 is 10 and f of 6 is 34. You don't really do anything different. In fact, it might even be wise to just write these as coordinate pairs, because that's all it is, right? When you have this function notation, it's f of x equals y. So this is the x and this is the y. So if it helps, you just write it as coordinates. So the two coordinates here being 0, 10 and 6, 34, and then you can just approach it like you did the problems before. So what's my change in y? Careful. 20 what? From 10 to 34. 24. Yeah. 26?
Oh, it's 24. Sorry, I thought it was 36.
Yes. Oh, yeah. It might just be my terrible handwriting. Yeah. So 24. What's my change in x? Yeah, plus 6. So my slope here would be 24 divided by 6, 24 over 6, which reduces to what? Yeah, that's nice, yeah. It's always nice when it reduces like that. Okay, so my slope is 4, and then what's my y-intercept? This is something that's implied through the given information. 10. Yeah, you're looking for that 0, whatever. So the y-intercept is going to be 10. We got our slope, we got our y-intercept, we're good to go, we can write our equation. Oh, you can't see what I'm writing. Let me zoom out just a tad. So y equals 4x plus 10. So with this modeling question, it says that in 2000, I guess that was probably before any of y'all were born, right? Yeah, but at this point, the cost for college tuition was about $14,000. Wow, those were the days. Yeah. And Kate, you're looking for colleges right now, right? All right, so kind of got off track there. So yeah, in 2000, the average cost for tuition was $14,000. In 2010, it was about $18,000. If we let 0 correspond to the year 2000, what's the y-intercept? So basically, like, you're given a coordinate embedded in this problem, right? If we're going to let x equals 0 be 2000, what's the, the y value or the dependent value that's associated with that? 14,000, right? So if we're going to let x equals 0 be 2000, then we've got a coordinate 0, comma, 14,000. And so that's going to be our y-intercept. I mean, that's basically our answer there, is 14,000. If we want to find the slope or the rate of change, what we need is like another coordinate to help us figure that out. So the second piece of information says in 2010, the cost was about $18,000. So if x equals 0 represents 2000, then x equals 10 will represent 2010. So we have 10 comma 18,000, right, as our other point. So if we're trying to find the slope, we're going to do change in y over change in x here. So the change in y, how do I get from 14,000 to 18,000? Plus 4,000, right? And then the change in x would be our change from 0 to 10. So plus 10. So we got 40 divided by 10 is what? 400. Yeah, 400. Use a calculator if you're not sure. The easy way to figure that out is just to like cross out one of the zeros. And that'll give you your answer. So what does this represent? Like, okay, 400 is the slope, the rate of change, but like, what does that mean in the context of this problem?
Every year the tuition goes up by $400.
Yeah, every year the tuition will, on average, go up by $400. Per year, that is, right? Like, gotta keep that in mind. All right, so we've got the slope, we've got the y-intercept. Now we can write a model or an equation to model this situation. So we would have y equals, our slope is $400 a month, a year rather, x plus our y-intercept, or the cost in the year 2000, which is 14,000. Now, this model is linear, right? Which means that the cost is, you don't have to sketch this out, but that the cost is going up like this, right? It's going up in a line. Just so you know, that's not exactly how the increase in tuition works, okay? The cost is probably a little bit more exponential, where it sort of curves up like this. So this price that we're about to get in 2020 is probably not going to be very accurate. So when we get this number, I want you to sort of like take it with a grain of salt. But assuming our model is good through the year 2020, let's use the model to predict what the average tuition cost would be. So what number do I want to plug into x there? How many years since 2000 is 2020? Yeah, 20 years, right? So we're going to substitute 20 in for x, and then calculate our number. So y equals 400 times 20 plus 14,000. This is something you could put in your calculator. You could probably do it by hand. I don't know. 400 times 20 is 8,000 plus 14,000. Maybe you can't do it in your head. I don't know.
22,000.
22,000. There you go. Yeah, and I mean, I guess there's probably some colleges you could get into for this amount, but I don't think that's very reasonable for many.